Hey all, so in this section we're looking at the algebra of functions. We'll start off looking at the four basic operations: addition, subtraction, multiplication, and division, both while evaluating functions at a point, and then also just working with the equations themselves. So let's get into it. For this first example, we're going to be given graphs as our prompt. For most of these, we'll be given equations, but we're starting off with graphs. So what it's asking us to find is to go f plus g evaluated at 2. This first graph is f, the second graph is g. Another way of thinking of this notation, pen out, there we go, is this means f of 2 plus g of 2. So this and this mean the exact same thing. I feel like this one is easier to see what it's asking. Find f of 2, so we can find that right there. It's 3. And then add to that g evaluated at 2. So there's 2, so it'd be negative 2. And that result would be 1. So that would be f plus g evaluated at 2 comes out to 1. Again, the exact same notation you'll see when we get to the equations. We could add the equations first and then evaluate, or we could evaluate first and then add. We get to the same answer, hence there's two notations. They mean the exact same thing. So with that, f of 0, let's see, when x is 0, the output is 3. And then subtracting g of 0, so when x is 0, the output is negative 2. And so then 3 minus negative 2, careful with that double negative, would come out to 5. This one is a multiplication, so f of negative 4, so it looks like that's going to be 0. So it doesn't really matter what the next one is since this one's 0. And then g of negative 4 is also 0, so 0 times 0 would just equal 0. And then f divided by g evaluated at 1. So when f is 1, or the x is 1 on that, the output is 3. And g of 1 would be negative 2. And we don't love negatives in denominators, so I'll just rewrite that as negative 3/2 that way. Okay, so for number 2, same idea, but this time given ordered pairs. So, and again, h of 25 plus g of 25 would mean the exact same thing. So this time instead of graphs, we have lists of points. H evaluated at 25 would be negative 18. G evaluated at 25 would be 5. And then negative 18 plus 5 would be negative 13. This time we're evaluating at 4, so H evaluated at 4 would be 3. And then take away G evaluated at 4 would be 2. So that one comes out to 1. Same thing here, multiplication, division. So H evaluated at 1 is 6. And G evaluated at 1 is 1. So 6 times 1 is 6. And then same thing, but now division this time. So H at 16 would be negative 9. G at 16 would be 4. And that doesn't simplify, so that would be how we would leave that. So pretty straightforward. This next round will be same idea, but now we're given functions that we have to actually plug into. And then here's where we kind of have a choice. F plus g of negative 2. So remember that means the same thing as f of negative 2 plus g of negative 2. So I can either evaluate each of these functions first at -2 and then add them together, those two results, or I can add the two functions together in terms of the algebra and then evaluate at -2. Depending on which one seems easier is which one I do. So for the adding and subtracting, again, it will work either way. I think for me, probably my preference would be to combine my like terms algebraically and then evaluate at 2. I feel like I make more errors just on the arithmetic than I do on the algebra, but that's just kind of my preference. I could have parentheses around this if we saw it just probably written out in a book. It likely would. With addition, it doesn't really matter because there's no sign to distribute. When we get down here to the subtraction, then the parentheses are going to matter more. So for me, I would probably put, and again, I could just put -2 in there right now and do all the math and get the answer. Or I could also say 5x plus x makes 6x, and then -2 plus 3 would be a 1 right there. And just simplify that a little bit so I have a little less evaluating to do, but they both get it done. When you're plugging a negative number in, remember to be careful with those parentheses, because this is really -2 times -2, so this is going to come out to a +4. Without those parentheses, that comes out to -4. And let me just do a quick reminder of why that is. -2 quantity squared means -2 times -2. You have a pair of -2's multiplying, so it's positive. If you have -2 squared, that actually means -1 times 2 times 2. It's the negative of 2 times 2, and this one comes out negative. When we're evaluating, we're always plugging, the square is operating on the sign, so careful to plug in this way. And now that we have that all plugged in, we can just say 4 minus 12 plus 1. And 4 minus 12 plus 1 would be down 8. Back up 1 would be -7. Same thing down here for this subtract. The only difference is with the addition, we're adding both of these, so there's no sign change. We're just adding x plus 3. But when we're subtracting x plus 3, but we got to be careful to get the parentheses so that we actually are subtracting the 3, not just the x. So then from there, we'd have x squared, 5x minus x, that would be 4x, and 2 minus 3, and that's where the error happens. And you're welcome to rewrite this as minus x minus 3 here, and just show that distribution written out. But -2 minus 3, oops, I need an x right there. -2 minus 3 would be -5. And then we would just evaluate that at 4. So let me scoot this up a hair. So 4 squared plus 4 times 4 minus 5. So that will be 16 plus 16 minus 5, so 32 minus 5, and that should be 27. These next two, similar, they're the same f and g that I have up above, so I'll just write those out right here. And then g was x plus 3. So multiplying, I would not multiply that all out. I'm going to write it out and then tell you you really don't need to. So f evaluated at 0 would look like 0 squared plus 5 times 0 minus 2. And g evaluated at 0 would be 0 plus 3. I would not go to the trouble of doing all that FOIL and then collecting terms when I could just plug straight in here and make two numbers and multiply them. So to me, for addition and subtraction, it's easier to combine the algebra first, but for multiplication or division, it's easier to me to just plug it straight in, especially if this happens to be 0, because then all this drops out, and you're just left with that negative 2 on the end. 0 plus 3, right? That's just going to be 3, and we got negative 6. And then this one, so it's just evaluating these at negative 3. And again, doing the there isn't really algebra to do first. I wouldn't want to actually divide that out before plugging the negative 3 in. So we'll just go negative 3, again, careful with the quantity squared there, plus 5 and negative 3 and minus 2. That is all over, negative 3 plus 3. So if I work out this numerator, that's going to come out to negative 8. But if you look at the denominator here, negative 3 plus 3, that's a problem because that comes out to be 0. And you may remember from a previous math class that division by 0 is undefined. And so in terms of the computer, what you would put in is DNE for does not exist. And that's what we're going to use in the system throughout when we run into issues like dividing by 0, where it's undefined. The next round of problems here is similar to the last, except if you notice it's x here instead of a value. So this is literally just having us combine, do operations with these two equations that are given. So f plus g of x is again f of x plus g of x. Those mean the exact same thing. So this would just be x squared plus 5 plus x minus 6. And so x squared will go descending order, so plus x plus 5 minus 6 should be a minus 1 right there. Subtraction, same thing, we always have to be a little bit careful with that sign. So x squared plus 5, and then minus, you get the parentheses around there. This time let me actually show that distributed out. So minus x, and then minus and minus would make that a plus 6. Again, you can do that step in your head if you want, or you can physically write it out if that helps you to keep the signs straight. Minus x, and then plus 5 plus 6 would make that plus 11 when I combine those up. F times g, so this time we do have to do the FOIL since that's what it's asking for. So that's going to look like x squared plus 5 and x minus 6. So doing our first, we'd have x cubed, outside minus 6x squared, inside minus 5x, and last would be minus 30. Actually that should be a plus 5x right there, so 5x and then minus 30. No like terms. This is cubed squared to the first and constant, so nothing to combine. So that's as far as we can go on that one. And then for the division, about all we can do is just write it over and under. So x squared plus 5 is our numerator, and x minus 6 would be our denominator. And then the last thing we're going to look at in this section is it's basically we're going to use the difference quotient as practice with function notation. And the difference quotient ends up being a really important concept if you have to go on to Calc 1. This is the basis of derivatives. You'll see this in the definition. What we're doing there, without going too much into it, because again we're more using it as a practice for reading this notation, but we're basically finding slope. And if you don't remember slope, we'll see it in the next chapter. But this is, if you do happen to remember the y2 minus y1 over x2 minus x1, that is what this equation right here is, but in function notation. I think I'll hold up there on it and just go to showing how we're going to use it in this course, but it will definitely reappear. So for the function f of x equals negative 5x minus 1, evaluate and simplify. So there's our difference quotient. Our difference quotient says that we're going to take f of x, f evaluated at, f of x plus h. So this function evaluated at x plus h, we're going to subtract the original function, the f of x, and we're going to divide all of that by h. And as the difference quotient is is essentially slope, as I was saying above. If you happen to remember y equals mx plus b, the slope of this line is -5. So if we do this right, we should end up with just -5. So let's give it a try. So f evaluated at x plus h. That means everywhere there's an x is going to be replaced by an x plus h. So if you think about it, if this said find f of 7, we put a 7 right there for x. But instead of a value, it's saying x plus h, so x plus h goes in for that x. And then -1. So that right there is f of x plus h. And then we are to subtract the original function, f of x. So very important that you get those parentheses there so that you get all of the terms subtracted, not just the first one. And then that's all over h. And then we'll expand this out and do some reducing. So -5x, and then -5h, -1, and I'll go ahead and distribute that negative through. So minus and minus there is going to flip that side to a +5x and a +1. Again, that's all going to be over h. If we do this right, everything that was in these parentheses, everything that was f of x, should cancel with something earlier in the problem. So here we have a +1 and a -1, and a +5x and a -5x. And that should happen every time on these. The other thing that should happen is this h in the denominator, assuming we don't make any errors, should reduce with what's left. And so if you look, the only term left in the numerator is -5xh, so cancel those. And there's that -5 that I was saying is the slope of this line. Again, if you don't remember that, that's okay. That's coming up in the next section. But that is what difference quotient does, is it finds slope. It just lets you find it for things that are non-constant, which is what Calc 1 ends up being about. So for this next one, it's a little more involved because it has that squared. So f of x plus h is going to look like 5x plus h squared plus 3x plus h minus 6. A really common error is for students to get the x plus h in the squared one, but then forget that they have to evaluate all the x's, so careful not to miss that one in the middle. And then we're subtracting our original function, which is right here. Oops, squared. And then that is all over h. So this we're going to need to expand out, and I think right up here I am going to go ahead and just do this little bit of kind of scratch work, mostly so I don't have to rewrite this 2 times because it's kind of cumbersome. Oops, plus. So x times x is x squared, x times h is xh, and then on the inside we'd have hx, but let's write it in the same order, xh, and then h times h on the end is h squared. Again, if you remember that shortcut, that's cool. We will review it when we get to the factoring review, but for now you can just do out your steps and FOIL it. And so we get x squared. This is 1xh plus 1xh, so that's going to be 2xh's plus h squared. So that is this piece FOILed. And I think I will just write that out as it is right now, and then come back and do that all as kind of one line. Okay, so then we're going to go ahead and distribute through our parentheses. So up front here we're going to have 5x squared plus xh plus 5h squared. And then we'll distribute that 3 and get 3x plus 3h minus 6. And then we'll be careful to get that negative distributed, or you can think of it as a minus 1 that you're multiplying through. So that's going to be minus 5x squared minus 3x, and minus minus is going to make a plus 6. I'm just going to do a short little line in here. I feel like I'm going to end up getting off and crossing out half my equation otherwise. It's still bugging me, so okay. From here, like I said in the last example, if we're doing this right, everything that was an f of x should cancel out something earlier in the problem. So we have a plus 6 and a minus 6, minus 3x plus 3x, minus 5x squared plus 5x squared. And then let's rewrite what's left so we can get a little bit better look at it. So 10xh plus 5h squared plus 3h. And then the second thing that should happen is this h should cancel with all of these above. So that would be 10x, and then here would leave us 5h. Remember, this h belongs to all three terms. You can think of it as three separate canceling problems, and plus 3. So that would be our difference quotient. Again, what that does ends up being actually pretty significant, but for today we'll just leave it there as an exercise in function notation, and a good little review of some algebra as well. These look kind of daunting to start. Once you can do one of them, you can pretty much do them all. They're all the same basic problem, but they are a little long, but not too much creativity. That's about what I got for this section, and yeah, hopefully that made sense.